Okay, so let's go ahead and start by reading the statement up at the top. It says, Axel and Anisa pay for and share memory storage at a remote internet site. Their plan allows them to upload 250 terabytes or less of data each month. And then we're going to let X, let's go ahead and underline this. Let X represent the number of terabytes Axel uploads. And let's go ahead and let Y represent the number of terabytes Anisa uploads in a month. Okay, so using that information, go ahead and do 1 through 4 together with your groups. 1 through 4 together with your groups. Go ahead. Okay, so looking at the first scenario, 50 terabytes for Axel, 120 for Anisa. Does that fit within their plan?
Yeah.
Yeah, it does. Okay. What about 135 and 100?
Yeah.
Yes. What about 100 and 150?
Yes.
Are you sure?
It's 100. It's 250.
Okay, they add up to 250. Are we allowed to be at 250?
Yes.
Let's go back up and read and make sure. Okay, it says it allows them to upload 250 terabytes or less. 250 works, right? If it said less than 250, then 250 wouldn't work, right? So it's very important what verbiage they specifically use, okay? And then what about the fourth scenario, 162 and 128? Yeah, it's a big no. Okay. After that, it wants us to write an inequality, okay? So what are we representing Axel and Anisa by again?
X and Y.
X and Y. They're sharing data, so what do we want to do with that X and Y?
X plus Y.
Yeah, we want to add them together, so I have X plus Y. And then what is their restriction?
Less than or equal to.
Okay, so we're at 250. Do we want... Okay, we do want less than or equal to because we want their data, which is X plus Y, to be less than or equal to 250. If you flipped it around, that's fine. Just make sure if you have 250 and then X plus Y, your sign would be greater than or equal to, right? Because you want the 250 to be bigger. Okay? After we get that inequality, the last two problems should be pretty easy, right? Because it just wants an inequality that represents the scenario if Axel has 100 terabytes. So that would be 100 in for Axel plus Y is less than or equal to 250. What if Axel used 100 terabytes? How many terabytes could Anisa use? 150 or
Less.
149 or 102 or 102 and a half or 102 and 3/4 or 102.5643, right? There are endless possibilities of different combinations of data that they could use, right? Not necessarily endless, but a whole bunch, okay? Same thing if Anisa is at 75, then I have Axel X plus Anisa 75 is less than or equal to 250. Again, many scenarios where Anisa uses 75, Axel would use a wide variety. Okay? So, let's look at the graph of that. So, go ahead. Okay, up at the top it says, the graph below represents the possible values for the number of terabytes that Axel and Anisa can upload. An ordered pair X, Y represents the number of terabytes that Axel and Anisa upload. For example, the coordinates 100, 75 mean that Axel uploads 100 terabytes, Anisa uploads 75 terabytes. Okay? So we see on this graph that there is a big shaded region, okay, with a whole bunch of points in that shaded region. So let's just check on the one that they gave us, 100, 75. So that would be on my graph. I come over to 100. It looks like each tick mark is 10. Up to 75. So that would be the point 100, 75. Graphically, does that fit within our region? Sure does, right? So basically what this is showing us is that any ordered pair that you can imagine that is in this shaded region would be an answer to this inequality, would make this scenario true. So you guys are going to test some, okay? So go ahead and do problem 5 together with your groups. Go ahead. Okay, so the ordered pair 200 comma 50. That's on the borderline, right? Is the borderline of this problem okay to use? Yeah, it is, because remember earlier on warm up we talked about solid versus dotted lines. Solid borderlines are when you're allowed to take the values from that borderline. In this case, since we're equal to, right, on our inequality we were less than or equal to 250, we're allowed to use that borderline, so that one's a yes. What about 150, 150? That's a no, that's outside the shaded region. 225, 25? That one's on the borderline again, which is okay. 20 comma 120? That one's yes. What about 120 comma 200?
No.
That one's definitely out. Okay, good. So basically all I wanted you to get from that is that we can have a variety of answers. Okay, that's why that shaded region is there. Any ordered pair that's in that shaded region is good to go. It will make the inequality true. Okay? All right, let's go ahead and get into the nitty-gritty of actually graphing these. So go to the last page. And there are 2 try these problems up at the top for you to do, please. So go ahead and do the 2 try these. I'll give you like 30 seconds. That's all it should take you. Okay, so for A, negative 2 is going to be in the middle. What kind of dot do I have there? This one's going to be closed because it's equal to. So closed dot. And then it says x is smaller, so I want to go back to the left. Okay. On B, 5 is going to be in the middle. What kind of dot do I have here? This one's going to be open because it's not equal to. And then it says x is bigger, so I'm going to shade over to the right. Okay. So remember, we want to make connections between the shading and we want to make connections between the dots in our lines, okay? So let's look at example A together. So example A, and this is why we practice this on warm-up, is basically just like the problem that we did on warm-up except for a couple things, okay? So it's already in slope-intercept form, right? It's already in y equals mx plus b form. So I'm going to go ahead and identify my m and my b. So m is always the number next to x. So what's my m here? 2. And remember, anytime I need a rise and a run, I can always put it over 1. So 2 over 1 for my slope. And then what's my b? B is a number next all by itself. So that's going to be 3. So graphing this, b is where you begin, m is where you move. So let's zoom in on the graph here. B is where I begin, up 1, 2, 3 on the y-axis. And then m is where I move, so up 2 over 1, up 2 over 1, up 2 over 1. Can also go the opposite direction, down 2 and left 1. As many as you need, okay? Now take a step back for a second and look back at your inequality sign, okay? Because that inequality sign dictates the rest of my graph. So the inequality sign here is less than or equal to. So I need to first know, is it dotted or solid? Solid. So it's going to be solid. We have a solid dot, right? Or a closed dot on a number line. So that equates to a solid line on my graph. So I can go ahead and put my solid boundary line in there. And remember, that solid boundary line means I can take those values on that line. And then I need a shading, okay? There is one disconnect, okay? All of the inequalities that we've done so far have been single variable inequalities. We graph them on a number line. That's kind of like one dimension. Okay, we are looking at 2 dimensions. We're looking at the x and y axis. So we have to kind of forget about left or right, and we have to remember up or down, okay? Because now we have y by itself rather than x by itself. Okay, so that says y is smaller. Smaller we are going to relate with down. Bigger we're going to relate with up. Okay, so y is smaller. So put your line or your finger or stylus on your line and then just go down from it, and that is the area you should shade. So I just shade that entire area below. Which means, again, just to reiterate, any ordered pair in that shaded region, or in this case on that boundary line, is good. If we plug it into our inequality, it will make that inequality true. Okay? All right, let's try B. Okay, B, just like the second one that we practiced, is not in slope-intercept form. So I need to put it in slope-intercept form, meaning I need to get y by itself. So I need to get rid of my x term, so I'm going to subtract x over to the other side. So I have 2y is greater than 8 minus x. What number is in front of x right now? The imaginary 1, the negative 1 there. Okay. So then when I divide by 2 on every piece, I can see a clear slope and a clear y-intercept. So I have y is greater than, remember I didn't divide by a negative, so no need to flip my sign. 8 divided by 2 is 4. Negative 1 divided by 2 does not divide nor does it reduce, so I leave it alone. And the x pops out beside it. So this is now in slope-intercept form. Now I can go ahead and graph. So what's my m? Yep, negative 1/2. And what's my b? 4. So let's go ahead and graph my boundary line. So y-intercept of 4, 1, 2, 3, 4. A slope of negative 1/2. So that's down 1 over 2. Down 1 over 2. Down 1 over 2. Can also go the opposite direction, up 1 and left 2. Okay, and then once I have my points for my boundary line, I need to go back and look at the sign again, remember? So I go back and look at my inequality sign. Always make sure you're looking at the last inequality sign after you solved. Because remember, in the process of solving it, if we have to flip our sign, that's obviously going to change the shaded region. So you got to be careful and always look at your new sign, not the original sign. So based on my sign, am I going to have a dotted or a solid line? Would you have an open or a closed dot? You would have an open dot, so this is going to be a dotted line. Okay, so all I do to show dotted on my lines is just put a little dash in between here.
She did not. Okay, go ahead.
Just like that. Okay, any questions there? And then we need the shading part, right? So again, based on our sign, are we shading above or below? It says y is bigger, so I'm going to shade up above. So I'm going to shade this triangle right here. Okay. So let's go ahead and practice. I'm going to have you try these A and C together with your groups. Try these A and C together with your groups. Go ahead. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Can also go the opposite direction. Down 3 over 1. Down 3 over 1. This is going to be a dotted line. So I'll just put my little dashes in here. And remember, a dotted line means I cannot use values on that line. Okay? But I do need my shaded region. It says y is smaller, so I'm going to go down from my line and shade this area. So any ordered pair inside that shaded area is fine to use. In this particular case, we can't use the border line, but everything in that shaded region can. Okay? All right, looking at C, we have a little bit of work to do up front. So we need to subtract 3x from both sides. So I have negative 4y is greater than or equal to negative 12 minus 3x. Divide by negative 4 on every single piece. And I end up with y is less than or equal to, right? I had to flip my sign there because I divided by a negative. Positive 3 plus 3 over 4x. So y-intercept is up 1, 2, 3. Slope is up 1, 2, 3, and over 4. Up 1, 2, 3, and over 4. Can also go to the opposite direction, down 3 and over 4. This is going to be a solid boundary line because it's equal to. And then this says y is less than, so again I'm shading down below that line. So all of this area right there. Okay, I do want to take a second and look at a special case line. Okay, so scroll over to D. And remember, a special case line is a special case because it only has an X or a Y in it. Okay, so since it only has, this one only has X, I can only plot a point on the X axis at 1. So X axis at 1. And then my line through that point is going to be opposite the axis. So since my x-axis is left and right, my x equals line is going to be up and down. So this line is going to be up and down through that point. Is it going to be dotted or solid? Dotted. So I'm going to have my dotted line through that point. And then this is the one and only one case that you can't do above or below, right? Because you can't go above or below this line. So x is bigger. Just revert back to your number line skills. On a number line, it was always to the right where the bigger numbers, so that's where we're going to shade here. But that is the one and only one instance that you are allowed to think about left and right. Okay, you should always be thinking up and down. So if it was a y equals line, y-axis is up and down, your y equals line is going to be left and right. So it would be a horizontal line, and then you can shade appropriately there. Okay. Any questions?